Hello everyone. Hope all of you are doing good. Do you remember in our last class we discussed about SDLC, which is Software Development Lifecycle? You remember that, right? Now I told you that we will be visiting the sprint planning since we couldn't fully explore it before. So let's take some time and dive into it. Once we are done, we'll move into the next step. Okay? Now, let's talk about sprint planning. Sprint planning. So, what is a sprint planning? Sprint planning is a key event within the Scrum process. It's where the team plans and organizes the work for an upcoming sprint. So, they plan and organize. Now let's highlight two important questions on sprint planning answers. Okay. Number one is what can be delivered during the sprint? One is what can be delivered. And the second one is how will the work be done? Work be done. In Scrum, a sprint is a short time boxed period, usually 2 to 4 weeks. So it takes 2 to 4 weeks. 4 weeks. Where the team works towards completing a specific set of tasks or user stories. Now let's look into this as more details. So what is the role of sprint planning in Scrum? Now you can think of sprint planning is a part of larger process. It comes from a refinement session. It comes from a refinement session where the developers and testers are collaborated to estimate the effort required for tasks and identify roadblocks and dependencies. For example, let's say we have sprint 1 and 1 to 4, okay? So sprint 1, sprint 2, like this to sprint 4. Sprint planning for sprint 1 might start on on January 1st, but the actual software development begins on January 10th, after the refinement session. So actual process usually starts after, hmm, wait, after it usually starts after the refinement session. session. So, during this planning stage, we determine which tasks or user story to prioritize. Now let's understand the user stories. So let's talk about the user stories. User stories. Do you remember our discussion about user stories? Each story represents a small, actionable piece of functionality for the product. For example, in sprint 1, we might work on user story 1. Let's say we are creating a login feature. Once we have planned and completed sprint 1, after the completion, we move to user story 2. Like we will be implementing an add to cart feature or something like that. So this process is sequential, like sprint 2, sprint 4. We'll have to do it step by step. First this, then this, then this. We complete planning for the current sprint before moving to the next. This ensures that we will be focused and we'll avoid any confusion. Okay, now prioritizing features. Let's talk about building a website. Which feature would you deploy first? Like we'll be deploying a login button, or contact button. Which is more important to us? Of course, the login button, because users need to log in or create an account before they can access other features. Here's another example. Like user story one has registration page, then user story 2 has login functionality, user story 3 has add to cart, and so on. In sprint planning, the team decides the order of these stories, focusing on building essential features first. Let's move on to time frame and points of sprint planning. Every sprint is a time box period of 2 to 4 weeks. Okay, so a 2 week sprint period equals 2 week sprint period equals 14 days, which we refer to as 14 points. 14 points. 1 point is equal to 1 day of work, which can be like around 8 hours. So these points reflect the relative effort required for developers to write a code and build the product, and testers to test and validate it. This makes it easier to estimate and work workloads. and plan workloads. So we'll be planning and estimate our time. Now let's move on to agile process. Agile process. Once sprint 1 and 2 are completed, the business analyst revisits the backlog. They go back to the product backlog. There, they conduct a refinement session to prepare for sprint 3 and 4. Okay, then the process repeats. The business analyst reviews user stories, the team estimates effort, and planning continues. This approach is a hallmark of agile methodology, emphasizing continuous development and flexibility. This cycle continues until the product is complete. So he again reviews user stories, the team estimates efforts, estimation. Then the planning continues. Now let's take a closer look at the Agile methodology. Agile is a continuous development process. There's no pause until the product is ready for release. The team works on one sprint at a time. One sprint at a time. This ensures the product evolves incrementally with frequent feedback and adjustment. Adjustment. Now, Agile methodology is a flexible and iterative process. It involves multiple sprints, such as building upon the previous one. When you are working on sprint 1 and 2, the respective sprint planning 1 and sprint planning 2 will already be completed. At this stage, user story 1 and 2 will have undergone the pre-refinement process and refinement session. Once refined, these stories move into the sprint development phase where they are implemented and delivered. So they go to from refined to sprint development phase. Then they're implemented and delivered. But here's the key point. While development team is working on sprint 1 and 2, the business analyst doesn't stop. He starts working on already user story 3 and user story 4. So the business analyst will schedule wait schedule new pre-refinement process. Then they will collaborate. Okay, they will collaborate with the team to plan and estimate upcoming user stories. This process continues iteratively until the final software product is developed and released. Agile ensures all team members are continuously engaged, leaving little room for downtime. This ongoing involvement is what makes it more dynamic and repetitive. So it is a dynamic and repetitive process. Now, what happens after sprint planning? Once sprint planning concludes, there comes regression testing and integration testing. So after sprint planning, there comes regression testing and integration testing. Regression testing. The developers and testers collaborate to ensure the features are functional and integrated into the system seamlessly. However, at this stage, developers have not started building it. Sprint planning is strictly about organizing and estimating work. Development begins after this phase. So, it's about organizing and estimating the whole work and start the development after that. So Agile method is a sequential method. Okay, it has different steps and stages. Like, let me tell you. Let me clarify the sequence of Agile phases to avoid confusions. So the first one is CRS. You know about CRS, right? We talked about it on the last class. Let me write them down and talk about it. Then the BRS, then pre-refinement session, then refinement session, then sprint planning, then development environment, then testing, then production, and maintenance. So in CRS or client requirement specification, requirements are collected from the client. Then in BRS, business requirement specification, the business analyst refines these requirements. After that, we go to pre-refinement session. Here, the initial discussion, they discuss initially to how to outline the scope. Then on pre-refinement session, they finalize user stories and ensure clarity. Then on sprint planning, they create detailed planning for upcoming sprint. Then in the development environment setup, they create an environment to develop the project. After that, on the testing phases, they include system integration testing, user acceptance testing, and pre-production testing. In the final step, they go to final deployment and support the product. You see, each phase is interconnected with each other, leading to a seamless development process. Now, let's talk about Confluence. We talked about it in the last class also. So, what is Confluence? Confluence is a software testing tool, which is a centralized platform where we can collaborate and share information, manage requirements, test case, and defect reports, store project document for access, easy access. Let me show you. So here is an image of Confluence dashboard. The main advantage of using a Confluence is that it keeps everything organized and accessible. Organized and accessible. So it enables the team to work more efficiently. In Confluence and other tools like Google Chrome, you'll often see something called the build version. Let's understand this using Google Chrome. When you open Google Chrome, let me show you an image. So it is Google Chrome. Here you can see the version. Okay, you'll see something like version. Uh, Here it is 131. So this indicates the version number, and the other number after that represents the number of times the build was corrected or updated before the stable release. So it was modified many times before it was released. There, the developers identified bugs and fixed different issues during the development process. They were corrected that many times before the current version became stable. This process ensures a reliable and consistent product for the user. Okay, now let's talk about the high level documents in Agile. So HLD. Agile project use high-level documents to provide an overview of the project. So, what are the high-level documents? High-level documents are the summaries of key elements in a project, designed to give stakeholders a quick overview. So, they are summaries of key element. They are not highly detailed or technical. They are just a summary. They are usually created for business stakeholders to understand the project without any technical detail. So, here is an example of high-level documents for by business product owner and business analyst. So some of the key examples can be CRS, BRS. CRS are created by business people and assisted by the product owner and the business analyst. They outline the client's needs and expectations. And in the BRS, it is a refined version of the CRS. So we can now know that Agile is a iterative process. It involves continuous collaboration and development. Sprint planning ensures teams are aligned and ready to start development. Now, a tool like Confluence help us streamline communication and document management. The wheel versions track how many iterations a product has undergone to reach its stability. So let's dive deeper into the life cycle of a project that focuses on requirements, especially the CRS and SRS, which is System Requirement Specifications. These documents are important for ensuring the product we are building aligns with the client's vision. Let's break this into step by step. Okay? Now let's talk about CRS. What is this document about? Well, it provides the business people, it is provided by the business people and to the product owner. It contains the features of the product and different constraints like time, budget, etc. Now, here's an important note. Non-functional requirements are not detailed in CRS. So don't expect to see things like performance or compatibility specifications here. It only focuses on what, not the how, okay? Now let's understand traffic. What is a traffic in, in the context of a website? A traffic refers to the time the number of users visits the website and their interactions, like how many time they have spent there. For example, high traffic websites like Amazon need robust systems to handle huge number of users at the same time. So traffic management is essential non-functional requirement. So it is a non-functional requirement. Non-functional. Now let's differentiate between what is functional and what is non-functional. Functional requirements are about what the system does. For example, Snapchat's ability to add filters or create reels. These are features or functionalities. Non-functionality requirements are like how the system performs, like how fast the web page loads, is the user's data safe, does the app work on both mobile on and laptop. So functional requirements is like features, and non-functional is like performance, security, etc. So let me emphasize this. Functional requirements are like what the car does. It drives, it has airbags. Non-functional requirements are how well the car does it, like about its speed, its safety rating, its fuel efficiency, etc. Now about system requirement specifications or SRS. Now moving on to the SRS, after the CRS comes to the SRS, this document dives deeper into the details. It's prepared by the business analyst with the help from the product owner and client. It includes functional requirements, so it includes brief functional requirements. Non-functional requirements are elaborated in details. So, detailed non-functional requirements like performance testing or security measures. NSS gives the team leader a clear picture of both what the system should do and how it should perform. But remember, not every company uses SRS in the workflow. Some do, some don't. For instance, Walmart might include it while Amazon might skip it. So it's about how the company wants. Okay, now let's go to FRD. FRD is the functional requirement document. Now there's another document to know about. It Think of this as a user manual for developer or testers. It contains every detail about how the product's features should function. If the SRS is a blueprint, then FRD is an instruction manual. Here's a fun fact. Before the SRS is finalized, the team holds inspection meetings. These are informal meetings to refine the document and ensure it's perfect before publishing. The Scrum Master may not be involved here. It's mostly the project manager or the product owner who's taking the charge. Okay, so it's an informal meeting about discussing the product. So this meeting can be like 15 minutes meeting scheduled by the Scrum Master or every morning to track the team's progress. These are called the quick overview. It is initiated by the Scrum Master. There, the team members discusses about the three things. So they discuss about three things. Three. Number one is what did they do yesterday? Number two is what will be they doing today? Will they do today? And third one is are there any blockers? This meeting keep everyone aligned and focused. Excuse me, and focused on the sprint goals. So, mm, so they are used. They are used to discuss. This meeting is used to discuss about the product development process more briefly. Now, let's go to another part. Now we are diving into a crucial topic in software development, which is understanding the relationship between functional documents, project plans, and the refinement process. We'll be covering several important documents like FRD, BRS, and how they fit into the project lifecycle. Now, The first one, scripting languages for development. To begin, when we talk about building a product, we're dealing with various programming languages. They typically include uh, HTML, CSS, JavaScript, PHP, etc. They are the scripting languages that developers use to build the functionality and design of a website or application. Now let's move on to something crucial, the payment gateway. This is always handled by a third-party provider. We don't establish our own server for payment transactions. We rely on trusted services like PayPal, Stripe, etc. In Bangladesh, there is also SSL e-commerce, which securely process the payments. Always remember, these all are external and secure services we use for transactions. So after that, we go to FRD. Next, we have the functional requirement document. This is created by the business analyst and is assisted by the product owner and the client. This is essentially the blueprint for the design of the project. So it is a blueprint. It's like a guide that outlines how the system will function and appear to the user. It contains overview of the product, which is a detailed description and different functional features like uh, so it let me tell you. So it has overview and functional features. So functional features like the search bar, user login options, and payment options. For example, on the website, you will see a card with options for currency sections. They are all functional elements that the FRD describes. Now let's talk about something important here. What you what I told you about the search bar menu or the product card is part of the front end of the graphical user interface or GUI. GUI. It is the front end of the website. Here, it is used for the interaction between the customers. Anything visible and touchable on the screen is the front end. This is what the FRD will describe in details. It also specifies the structure of headers, menu, buttons, telling developers how these features should behave. Okay, so it is the thing we see while browsing a website, like the design, the colors, the images. Now let's talk about the difference between FRS and FRD. Sorry, SRS. SRS versus FRD. The SRS describes the product's technical requirements like the performance, security, and system behavior. However, it doesn't get into the nitty-gritty functional details like what exactly the user will see or interact with. For example, the SRS will mention that the system should handle 100 users, but it won't specify the look and the feel of the user interface. So SRS won't have anything to do with the front end of the website. This is where the FRD steps in. The FRD is more focused on user interactions, about how the interface will look, how it will behave, what features will it contain. While the SRS outlines the system capabilities, the FRD focuses on those capabilities and present it to the users. So it goes to system capabilities and it goes the presentation. So they both are important documents, but they each have a specific role in the development process. Now let's talk about the acceptance criteria. Acceptance. We can begin, we cannot begin building the software with just FRD. We also need acceptance criteria to know when the product is considered done and ready for delivery. Okay? They are the conditions that must be met for the product to be accepted by the client. So they have different conditions. The FRD, however, doesn't need to contain this acceptance criteria, which is why we also need a project backlog. The backlog helps prioritize the tasks to ensure the product aligns with the client's visions. Now let's move on to project plan. This document is prepared early in the project and is typically created by the project manager. So project plan. It is created by project manager. It is the roadmap for the entire project, outlining its scope, objective, tasks, timeline, resources, and other details. So it can have different components like budget, timeline, then team members, then testing, and like how much the client is willing to spend, how long the software will take to develop, who will be the team members, various stages of testing which will be performed. Also, the development phase. The development phase is a critical phase. Think of it like installing an app on your phone. Once the product passes all the testing, it's deployed to the client or live environment. This is when the users usually can access the system, much like how you can use Facebook or Amazon after navigating to their website. There are also risk and backup plan. Risks and backup. Here, in any project, there are always risks like technical, budget, data loss, or lack of skilled resources. These are documented in the project plan so that the product manager can prepare a backup. For example, if there's a risk of requirement change, the product owner will have to communicate with the developers and testers to adjust the project as needed. The project manager's job is to ensure that these risks are mitigated and the team is prepared for any unforeseen issues. So it is like a, uh, it is like risk management and mitigation. Risk management and mitigation. Now let's talk about the product backlog and the user stories. This is a living document that contains all the tasks required to complete the product. You'll see a list of user stories which describes different features from the end user's perspective. Let's see an example. Here we have a user story like as a user, I want to see clear instructions on the registration page so that I can fill out mandatory fields correctly. But this isn't a complete user story. It lacks the scenario and acceptance criteria. Without this, it's incomplete. We use a format called Gherkin given when then to specify the conditions to a user story. Okay? So it is not complete. Now let's move on to BRS. The business requirement specifications is where you will find more detailed technical requirements. So it is a detailed technical requirement. It includes elements like API documentation and other technical specifications that are necessary to support the business needs. It also addresses the product, how the product should handle invalid credential or error message, and other technicalities involved in the interaction. It helps the developers to understand exactly what is needed to meet the business goals. Now in the now finally we are in the pre-refinement session. This is where the business analyst presents the BRS to the product owner and the project manager for approval. So business analyst presents the BRS to the product owner and project manager. After that, the Scrum Master organizes a meeting with the entire development team, like the developers, testers, and architects. So it goes to the Scrum Master, and he assigns team. During this session, we focus on prioritizing and defining the severity of the tasks. For example, if a sign-in button is not working, it's a priority issue because users can't log in. On the other hand, if a sign-up button isn't working, it might be a less severe issue because users who haven't uh, signed up yet can still interact with the site. The priority refers to how urgent the issue is for the user, while severity refers to how much the bug impacts the business. So the priority is about the urgency, and the severity is the impact. Now, what is priority? Priority is how urgent it is to fix a bug based on the impact on the customer or the business. Essentially, it answers the question, how soon should this bug be fixed? So it is about the bug fixes. Priority is generally ranked from priority 0 to priority 4, where the 0 is the highest priority, meaning the bug needs to be fixed immediately, and P4 is the lowest priority, meaning the bug can be addressed at a later time. For example, imagine you are managing a e-commerce website like Amazon, and you encounter a bug that prevents customers from checking out or adding different products. What is the priority of this bug? Since this bug affects the customer interaction transaction directly, which is the core of the business, it should be considered P0. Fixing this bug is critical to maintain the business operations smoothly. If the customer can check out or add product to their cart, they can make any purchases, which will immediately hurt the sales and customer satisfaction. Now, what is severity? It refers to how serious or impactful the bug is on the system or the business. It answers the question, which is how badly will this bug affect the system or business operations? So it is the effect. Severity ranks from 0 to 3, where 0 represents the highest severity, meaning the bug causes significant damages to the system, whereas the severity 3 represents the lowest one, meaning the bug causes minimal disruption. For example, if the same bug we discussed about earlier in Amazon, where the customer can add items to their cart or check out, what is severity? This should be S0 because it directly prevents customer from completing transactions, which is critical issue. And the system's primary functionality is compromised, leading to a potential financial loss. Now, how priority and severity work together? While priority is about how urgently the bugs needs to be fixed, severity describes how bad the bug is for the system. For example, a bug where most customers can still use the website, but one minor feature stops working, such as the sign up option, would be considered low priority but high severity. So, if there is a one minor feature problem, then it is priority 4 but severity 1. It is low priority because it doesn't affect a large number of customers. However, it's high in severity because the feature might damage the business's reputation or limit the business growth. In this case, you may want to fix it eventually, but it's not an emergency. It can be fixed by taking some time. Let's look at a few real life examples to make this more clear. For example, for example, let's talk about Amazon shopping cart bug. When you are logged into your Amazon account, but when you try to add items to your cart, you can't. This is priority 0, severity 0. This issue prevents customers from completing the purchase, so it should be fixed immediately. And about the severity, this affects the core functionality of the website. So it could result loss of sales and customer trust. And the second scenario is the about the sign up. Here the priority is 4 but severity is 1. It is a bug that prevents customers from signing up to the program, but most customers don't use these features. It is priority low because it doesn't affect the majority of the customers, so it can be fixed at a later time. While it doesn't affect the customer's experience directly, it affects the business ability to grow through affiliates, which could have long-term effects. So it is high severity. Now, for third scenario, spelling mistake. It is priority for severity. This is not urgent. When you notice a spelling mistake in the company or on the website, company's logo or in the website, customers can still make purchase and the business can still run smoothly. And the issue is minor in terms of functionality, but it could hurt the brand's image. Customers may question the professionalism of the company, so it is S2. Now about the fourth scenario where the website, here the suppose here spelling mistakes appear in the slogan on company's name. It is usually priority 3 and severity 2. Excuse me. It's not preventing customers from purchase, but it could impact the brand's image. So it should be fixed sooner or later, sooner than later. Although it could damage the brand's credibility, it doesn't affect the business ability to operate effectively. So it is severity too. When prioritizing bug fixes, you need to prioritize based on both priority and severity. If there is a conflict between the two, you should focus on fixing high priority bug first, even if they have lower severity. For example, if there's a critical issue preventing users from signing up for the website, that should be prioritized over a less critical issue like fixing a minor typing mistake. In a situation with both low severity and low priority, you can leave the bug to be fixed later. In a situation with high severity and low priority, you can still delay the fix, but it should be addressed immediately. Okay. Now, in pre-refinement session, your team will typically determine priority and severity, but won't decide exactly what will be built or fixed in the upcoming sprint. The goal is to assess which bugs are most urgent and how much they impact the business, but not to decide what to deliver in the sprint. For example, if the sign up page is working fine but there is a difference to the affiliate program sign up, The bug affecting the sign-up page should be fixed first, even though both bugs are important. Okay? Now, what is a refinement session? In a refinement session, the development team and testers they will review user story, then clarify the requirements, then estimate efforts and time, then they will define the acceptance criteria, then they will discuss dependency, and then they will prepare test. So they will discuss and define the user stories from the epic to understand what functionality needs to be developed. Then they will clarify the requirements and ensure that everyone understands the requirements in detail. And then they will estimate how long each task will take and which resources will be needed, like how many people, what kind of tools. Then they will agree on what will be considered done for each user story on the acceptance criteria. After that, they will identify any dependencies between user story or features. Then they will prepare a strategy that outlines how testing will be carried out for each user story. Okay, now let's talk about epic. What is an epic? It is in the refinement session, the development team works with the epic. It is essentially a large user story or feature that can be broken down into smaller, more manageable tasks or stories. So it is a large user story which can be broken into small parts. Think of the epic as a folder that contains all the related user stories. For example, in Epic 1, the team might be working with the registrations, login, search, add to cart, payment gateway functionalities, etc. So let's give you see it is an example of Epic 1. It talks about registration, login, search, add to cart, etc. This structure helps the team focus on a big picture first, then break down into small pieces to make development and tests more manageable. After that, in the refinement session, we have team assignment. In the refinement session, it's crucial to assign roles clearly between developers and testers. For instance, QA team 1 might be assigned to work on Epic 1, which is registration, login, search. QA team 2 might be working on Epic 2, which is navigation. QA team might be on Epic 3. So it is divided. QA 1 assigned to Epic 1. This ensures that each testing team is focused on specific epics or user stories. It also means that each team's test strategy or test plan will differ, as they are working on different parts of the software with unique features, functionality, and dependencies. Once the epics and user stories are clarified, the testing team will start preparing the test planning. Test planning and strategy. For test strategy, it is a high level of plan for testing, outlining the overall approach to ensure quality assurance for a given epic or user story. It will include things like test objective, like what needs to be tested, test deliverables, what documents should be provided, test tools, what kind of tools testing on will be used, test environment, the hardware and software required for testing. So for strategy, it has objective, deliverables, tools, environment. Now for the test plan, it is more detailed than the strategy and focuses on the specifics of how testing will be executed. It includes test plan includes test schedule, then entry and exit criteria. The test schedule is when the testing will start, when the test cases will be designed, when tests will be executed, and the test closure will happen. And the entry exit criteria is what needs to be in place before testing starts, when testing will be considered complete. During the refinement session, both the test strategy and test plan are refined and updated based on the discussion of the user stories and epics. Then before we start the actual testing, we need to identify certain assumptions, dependencies, and constraints. Okay, we have to add assumption, dependencies, and constraints. For high-level test assumptions, it is the conditions under which testing will occur. For instance, you might assume that all APIs will be ready by a certain date, or that developers will provide demo accounts for testing. Then the dependencies refer to relationships between features or user stories. Okay. For example, you cannot test the checkout process until the add to cart functionality is complete. Dependencies need to be clearly defined in the requirement session to avoid blockers later on. So you need to finish the product, finish the thing which is dependent on the others. Constraints are limitations that might affect the testing process. This could be a limiting testing environment, budget restrictions, or time constraints. These constraints need to be communicated to all team members to ensure realistic expectations. In order to effectively test features, test data is also crucial. It refers to the input content required to execute the test. For example, if you're testing a sign-in functionality, but you haven't tested the sign-up functionality yet, you will need a demo account provided by the developer to ensure that you have a valid data for testing. Okay? Otherwise, you will have problem on working on the signing page. Now, for the test execution and defect management, after the test plan is set and the necessary data is available, the testing team will begin the test execution. During test execution, the testers will run through the test cases and track any defects found. Then the defect management becomes important here as well. Any defect found will be logged and testers will follow up with developers to get fixes. In the test strategy, we also discuss how defects should be handled, where the defects are critical or minor, and how they should be prioritized. Okay, so after taking data, we begin the test execution. After the testing, the test closure report will be prepared. So the test closure, here it will have the summary. It summary of the testing activities, then problems, what kind of problems did they encounter, then results, after that, lessons. So in the report, there will be a summary about the tests and what kind of problems they encountered during the test, whether the test passed or failed, what worked well, and what could have been improved in the testing process. This report helps provide a final view of the testing phase and any improvements that needs to be made for future sprints. Now talk about the entry and exit criteria. The entry criteria is before testing starts, certain documents features must be in place. For example, developer must have written the code for feature before testers can start writing test cases. And the exit criteria is once testing is completed, it's important to have a checklist of what should be done before the sprint ends. This could include making sure all crucial defects are resolved and that all acceptance criteria for the stories have been met. The exit criteria is defined as the condition where all test cases have been executed and successfully passed. Once the test cases have been executed and verified and there are no issues found, it signifies that the test phase is complete. This criteria is crucial for testers because it helps them determine what the testing process is, when the testing process is done, and whether the software meets the required standards. The completion of this criteria means the software is considered ready for the next phase. So, in the entry criteria, there should be certain documents, and the exit criteria, it should have checklist. Now, let's do some tests. Uh, it is development environment URLs. Now, what is it? In a development environment, developers write and deploy code for specific features or functionalities. After the code is written and deployed to the server, a URL is generated. This URL points to the deployed web page where the testers will access the application and perform the testing. For example, once the developers finish coding a feature like a registration page login page, product page, etc. They will deploy it on the web and testers will receive a link to this page for testing purpose. As you can see, there are many links in this image. The tester's role is to check that the feature functions correctly by interacting with the page. They might check things like whether the registration form works as expected, if errors show up invalid input, on whether the page displays correctly. Now, to perform testing, test data is essential. The data can be provided by the QA team or directly communicated from the developers to the testers. In the case of testing a registration form, for instance, the tester might need a set of test accounts or test credentials to check different user scenarios. These credentials could include both valid and invalid data to simulate real-world user behavior. As a tester, your job is to access the functionality of the system. For example, when testing a login page, you can see about while testing a login page, you will need valid cred, sorry, credential, invalid credential. You need valid credential to check if the login works when there are valid credentials. You should also try wrong email password combination and verify the system displays appropriate error messages. You need to test all possible cases such as using an incorrect password with an incorrect email or vice versa. Edge cases are also important, such as empty fields or special characters in passwords. Now let's go to risks and assumption. In the risk and assumption section, any potential risks or uncertainties related to the product are recorded. If something unforeseen occurs, like a server crash or a sudden issue with a feature, it will be documented as a risk. This section will continuously update it throughout the project lifecycle. Developers, testers, and business analysts communicate regularly to address these risks and assumptions. It can be like server crash, feature issues, etc. Now, pre-refinement and refinement session. The pre-refinement session focuses on early planning and rough estimates. It helps the team identify any potential roadblocks or dependencies in the tasks. Whereas the refinement session is when the developers and the testers meet to provide more precise estimates, discuss roadblocks, dependencies. Now, what is the roadblocks? What are roadblocks and dependencies? Roadblocks and dependencies. A roadblock is a situation where the progress of a feature or a test is halted due to an issue. For example, if the tester is unable to access a test environment or lacks the necessary test data from a developer, this can create a dependency. Dependencies often arise when one feature relies on another and or when the tester cannot process without the input from a different team. For example, if a tester cannot access the data needed to test a feature, it creates a dependency on the developers to provide the data. These dependencies are noted in the minutes of meeting or MOM. It is a formal written record of the key points discussed during the meeting. It includes uh, risks, assumptions, action, and any other important decision made. It is shared among team members for reference. Now, what is sprint planning? In sprint planning, the team decides which user stories or features to prioritize for development and testing. This meeting ensures that each feature is completed in appropriate sprint cycle. User stories are broken down into manageable chunks, and the team discusses which features should be built first and which will follow later in the project timeline. For example, in a scenario, sign up should be developed first because it's a crucial feature for new users. Then comes the login because it is needed for the returning user. Contact us would be prioritized last because it's less critical. So the first one will be sign up, then sign in, then contact. In situations where a bug is found, the blocks that blocks users' functionality is uh, where the user is not able to log in. This bug is designated as priority zero, indicating it must be fixed immediately. The distinction is made between what features to develop first and which two issues fixed first. For instance, while the SANAP feature should be developed in the first sprint, uh, the priority zero bug related to the login should be prioritized for fixing during the sprint, even if it isn't part of the current sprint development task. Now, before a sprint begins, team checks entry criteria to make sure everything is ready. Okay, so they check for entry criteria, they check test plan, test strategy, then design. For test plan, this define the testing approach and how the quality will be assured throughout the project. For the test strategy, the high-level approach detailing how tests will be executed, what tools will be used, and what kind of testing will be done. And in the design documents, this outline the technical aspects of the project and provide the blueprint for developers and testers. As the project progresses, these documents are continuously updated to reflect new insights, risk assessments, and required changes based on actual development and testing results. Now, for development, tools like Angular are used. It is a framework that developers use to create web applications. It is Angular. It helps in writing the code for features like the login page where the HTML, CSS, and JavaScript are combined to create the user interface. Testers also use various tools to help them track and manage their testing efforts, such as Jira, which is used to track the status of the work, including tasks and bugs. Testers may create tasks for issues they discover and assign priorities to those tasks to ensure they are addressed appropriately. Once the code is deployed, it is tested in the developer environment. But the software is not necessarily complete at this point. Okay? Developers often deploy specific features of a user story one by one, and testers then test this feature in isolation. This allows for a more focused and efficient testing process. So for user story one, they conduct test one. For story two, they conduct test two. There are two major types of testing. Okay, one is static testing and the another one is dynamic testing. Static, dynamic. In static testing, we test the software without running it. In this phase, the testers review and analyze design documents, requirements, and test plans. They may plan the test cases and identify different areas where testing will be necessary. This phase occurs before the actual test execution and is part of the quality assurance. Whereas in the dynamic test, the software is actually run and tested in the development environment. Then they execute the test and validate whether the functionality works as expected. This is the quality control phase where defects and bugs are actually found and addressed. So in summary, static test is about the mm, preparation. It is about preparing and reviewing the materials before actual execution. Where it is about execution, where we actually run tests and verify functionalities. So I hope I made you understand all these topics. If you have any questions, you can ask me, then we can leave. So it's all for today. I hope we'll see you in the next class. Till then, take care.